Welcome. Thank you for coming to my talk. It's beautiful C++ code told through the eyes of a failed AI prompt. It's a little clickbaity, I admit. Beautiful C++ code, what is that? And then also failed AI, oh my gosh, we all got to keep our jobs. All right. A couple things. First, the computer that I was going to run these slides on broke on the way here. So using my industriousness, I am now remoted into my computer back home. But I suspect there might be some delays, and so just so you're aware, if I'm doing this, that's why. Also, I'm Erich Lohrmann. I'm a senior software engineer at General Dynamics. I represent myself here and no one else. And all of this is all of my own opinion and not affiliated with any organization or anything else. I love C++ and a lot of other software things like Rust and other things like that. But English is my first language, but I've been a software developer for so long, so forgive me if this isn't clear. Hopefully I will clean it up in my articulation. It's not a study of AI prompting or any particular tool. I'm not going to name the AI that I used or the version. It's not really a study of C++ best practices for all projects and situations. It's kind of niche. And it's not a statement on what tool is the best. I believe firmly that tools are tools, and I don't care if you cheer for your hammer or not, it's a hammer. And this is, again, my opinion. I'm talking about a cool abstraction that I have had I've been able to use and work with in real life. And then this is kind of me building it again in a better way, and also using AI to get some experience with that, but then also to kind of see what it can do. And then in the process of all of that, of doing that and setting this talk up, I kind of failed at doing it in such a way that I thought it was useful. I thought it was fun, and I thought it was kind of a good, quick study of something that I thought was cool. So that's what I'm sharing here. All right, let's get on to it. So there's a system out there that's distributed, it's event-driven, there's more than one system. It's running across what we'll call multiple concurrent execution contexts, right? So threads or processes, depending upon the mode. It has strict non-negotiable requirements. No deadlocks, no race conditions, period. You gotta prove to me that that's possible. The system's abstractions are designed so that developers can make frequent changes, hundreds of commits per week. They don't need to understand or manage any concurrency constraints to do so. And most of the contributions come from junior developers or domain experts. So PhDs in physics or mathematics, they have limited expertise with C++. And a lot of them, electrical engineers, have more experience with C than they do C++. So how does that work? How do you meet all of those requirements? And underlying this particular system is this abstraction that we will talk about. There are other pieces of the abstraction, so it's not the whole system, but this is the thing that makes it go. Okay, it's a message passing abstraction. Why do you want to get excited about message passing abstraction? It's complex in its implementation, and this complex in the sense that a junior developer who is new to C++ is not going to be able to come back with it very easily, and will probably take some time to understand it. But the top level is very easy to use. I want to be able to put things like receiver in a class and default construct it, and it does the right thing. And then in main or some other top level abstraction, I have my services or my class basically object. And then I call get sender from it, and I store that for a period of time, and then I pass it to other services. And so in doing so, I make these connections from point to point, and the senders can send to the receivers, and that's very easy to explain and understand for most people. On top of all of that, my senders are copy constructible, so I can pass them around, so I can have many senders, but only one receiver. And why do I do this? Because that turns out to be very useful while not making it too difficult for me to reason about my receiver on the other end. So I would like to enforce all that in the code, and notice there's no type information associated with the receiver or the sender. I am not saying I'm going to send you all of these vectors or whatever. I'm not going to define a message-based type that all the messages have to fit into. So that is not present here, and is a requirement. In a loop or handle or whatever, there is this on my receiver and internal, right? Whatever. I have a dispatch function, and that dispatch function takes a list of lambdas. It could also be function pointers or member variable with standard binds. Member function with standard binds. These define a unary argument and a type. It's a user-defined type. It can be const ref. It can be copied by value, and based on the type, when that message gets received by the receiver, it does what's in the handle. Obviously, does the lambda function, and then inside that lambda function, you may do some stuff and then send on to another sender that you have. Okay. The key part about this is twofold. One, it's read top to bottom. I don't have to jump around to other files to find my registration functions. I don't have to do any of that. I don't have to anywhere specify register first message, register second user-defined message. It just works. And the second thing is, these lambdas are safe. It's all single-threaded execution underneath here. So there's no holding on to references that can come bite you in the butt. You can't do any of that unless you literally, access a null pointer inside of the function itself, or you start doing crazy things at the top level. This doesn't provide you thread guarantees without the rest of the system. So the rest of the system provides those thread guarantees. We won't be talking about that today.
How do you know that? I mean, you're capturing everything by reference. For all you know, all of them on all threads could be bound to the same global variable somewhere. How do you know that they're thread safe?
Because this is all single threaded. They're literally only accessed in this thread. Sorry, yeah, that's correct. We don't allow global variables in this. Okay, so we explicitly discourage our users from using global variables, and I should have specified that first. The idea is that every handle class is self-contained, so they're movable, and then you can't touch them after they get moved into their thread abstraction. Okay. So. Extra functionality. Receivers and senders have to be able to live in separate threads. Obviously, we need to be able to send senders and receivers. Otherwise, why not just write libraries and just follow all the way down? This also has a nice thing of being able to, you get the option of not using multiple threads underneath, but that's not here nor there. The point is that in our initial abstraction, we want to make sure that receivers and senders can live in separate threads. And then dispatch handlers. They have to be able to send messages to the queue that dispatch handler is running on, and we would like to be able to send those messages sometime in the future. This gives us some really nice capabilities, like being able to send ourselves heartbeats and stuff like that to do something periodically. It also allows us to then not worry about what event is happening or what happens when I receive more than one thing on the queue, because I only have one receiver, and so it can only handle them in a safe order. Okay, so this is very niche. It does not scale well with more CPUs. Typically, when you throw more cores at it, you've already kind of made the assumptions about what you're going to put in which thread. But there are small embedded systems where this is great. Okay, I only do as much work as I possibly have to, and I get out of the way for the other applications or processes that are running on my system. Okay, so we want to recreate with AI. Okay. Why? So we can learn about the internals of how this cool system works. So we can learn more about how C++ features tie together, and maybe practice our AI prompting, although I'm not really sure you can. One thing that I didn't do is I didn't access plan mode of any type. So I didn't get the AI opportunities to ask me questions, and I deliberately kept the prompts broad. Why? Because I wanted to see what it came back with when I was not specific about my requirements. And sometimes I got more specific and it seemed to get lazier and less nice. So I think it, and again, I understand that AI is a stochastic model and that it doesn't really think or do anything, but I'm going to talk like that because it's going to feel like it is as we go through. So here we go. So first prompt. I need a message passing channel abstraction in C++. That's as broad as you can possibly go. I didn't mention multiple threads, but it already gave me the thread-safe implementation and unbounded and bounded channel varieties. I find that if I'm super broad, it will throw a whole bunch of features at me and just pray to God that I want those things. Again, this will go away in like plan mode or whatever, but that's not how we did this. But then I stopped early because it used to be, I don't know, it doesn't do this anymore, but it used to be that like you could see the files as it was building out, and I could like click and see what it was doing, and then I could stop it early and whatever. So when I did this, I did that because I could see that it was only going to go through one message type. And, you know, this is probably obvious to this audience on why that's a problem. If I need a new message queue for every type in my system, I have hundreds of messages in my system. That's a pain. And then, of course, it becomes very, very hard to read and reason about. So that's not good enough for this particular project. Now, that being said, there's a reason it's kind of the default for the AI. This works for a lot of people in projects, and and they don't need anything more than this. And why complicate your abstraction if you don't need more than that? But it's not good enough for this talk, and it's not good enough for the system that I wanted to build. Okay, so when it continued, it started talking about standard any and type erasure, which is nice. There's a problem with this, which we will discuss towards the end. But yeah, and then it gives me different types of receives. I can receive with the standard optional standard any. That really sucks. I can do this receive as, where I cast to a specific type, and if it doesn't, it throws. And then it could also return a null op instead of throwing. So this is still kind of far away from where we want to go. But we live with it for now. And now we want to see if the AI lied to me. Now, here is the part where I confess something. So something happened here. I was doing this. I had a history of my prompts and my changes, and this was months ago, back when I, was doing this talk for the first time. And sometime between then and when I was finalizing this talk a couple weeks ago, that functionality changed to where it only saved the last iteration. So we're kind of looking at this last iteration that I had at the time, which was lucky because I did a couple prompts and then I moved to a different one to try to restart to do a different thing here. So we're going to look at this, and then we'll have to go back and do the typical AI thing and restart. But this is just to kind of give you a sense for the three major underlying abstractions, and we won't look at this more than once, I promise. Standard any's there. There's no templates, which is nice. But it also means we have to be at least C++17. I didn't specify that, but it's good to know. We have multiple condition variables. So there's this channel state class and the receiver and sender, which are 4 declarations, which is interesting because they don't happen again until here. And friend classes, when they are declared, they also act as 4 declarations. So it's just an interesting double include. I don't know. Maybe it's just for whatever. There's sender counts and receiver counts, which tells me that it's probably doing some type of reference counting, but we got to make sure. And then I also thought it was weird the fact we had friend at all until I realized that's private keyword. So whatever, and it's perfectly valid and it's fine, but it fooled me around the first time around. And then, usually it's either public first or nothing first. I checked Google to make sure I'm not crazy about this, and also kind of said the same thing, often leaving out the private keyword, but technically not wrong. There's nothing wrong with this. It will compile. Okay? So yeah, we are reference counting, and I hate the reference counting because it means every time I copy a sender, because of my mutex is actually and the reference are in that shared state, I have to lock it, and that's painful. That means every time I do a copy, I need to lock. Now, in the system that typically goes along with this, the use cases that typically goes along with this, yes.
In your prompt, did you specify that there was only one receiver?
Yeah, not in this one.
Okay.
So we'll get to that, yeah. The other thing is that, this was the super broad one. And the other thing is that because I don't have any operations in my channel state, I have to do locking at the top level. And also because of the way we're doing the reference counting, I have to do locking at the top level. So in the typical use cases for a system like this, it has been my experience that dynamic connections are kind of rare. So a lot of this happens in initialization. I pull up the threads, I hand them the services, I give them all the connections, set all the connections up, not necessarily in that order, obviously. And then I go and like the system kind of lives as it is. It doesn't need the dynamic. So this is not really painful to me. It's not a performance hit that I take except at initialization, which, may or may not be a big deal. But I don't like it. And that's kind of some of the theme of some of the AI stuff is that like it does things it didn't ask me about. Now granted, I didn't ask it to ask me about. But when you make those small changes, you get some of the stuff which is like, okay, but this caveat here, this caveat there. And then I was wondering about something like this, where in my copy constructor, if my state, if I have state, I lock it and immediately decrement it no matter what. And I thought, oh my gosh, that's gotta be a bug because obviously I would be incrementing this only by 1. I would never need to decrement this. But it's not true, okay? The AI does this right and I had it wrong. If my sender has a different receiver from the one that I assign it to next, then that state is in a situation where it needs to decrement. Okay, so the safe thing is to always decrement, and then you'll add it back as it comes. Only if there is state for there, right? Because you're copying it anyway, right? And the center becomes a thing. So this is a subtle issue that's that the AI caught and that I did not. Okay, so moving on. Again, the reference counting is really tricky to get right. There's like, that situation that I mentioned happens more than once. And it's kind of easy to see, like, why would I, my reference count go to 0 in certain moments? Oh, it's because I'm doing this other weird situation. And so, and then of course, making sure the standard share pointer, when it's moved out of, it becomes null pointer. And so, you got to make sure that you're not dereferencing it. It does all of that correctly, which is nice. And then this is what kind of like the actual sending function looks like. You see it does forward value referencing, universal referencing and forward perfect forwarding correctly, except it doesn't. And this is what I realized. I was looking through this and realized that the perfect forwarding was in there already, but I remember this being distinctive, that it had instead written two templated send functions, one with a single reference, L value reference, and the other one with a universal reference. So if you know anything, you know that can be slightly problematic because when you pass in an L value, it will go to the more specific one. Now, the AI literally copied the function. So is it something you would ever realize? No, right? Because the code that gets run is exactly the same. But it bothered me. So I asked it to fix it. And this is where I realized, oh crap, the history I had previously doesn't exist. And so, explains how it needs to make it cleaner and everything else. And then I realized that it had deleted my history of my chat and I needed to start all over. So like typical AI stuff, we had to start from the beginning. Now, we're going to repeat the experiment, but slightly differently. And we're not going to go through the code again because this implementation is going to be significantly different. So now I'm a little more specific, right? I say make it easy for the developer who's using the abstraction to find the correct type on the receiving side. Think about how broad that is without having to know the details of the underlying abstraction. And then this abstraction can support multiple senders, but you can safely assume a single receiver for each channel. I did not ask it to enforce that. I only asked it to safely assume. So we said, okay, I'm going to build this around standard variant plus standard visit. Okay. So I know immediately what it's going to do. It's going to require me to write types out for all of the message types that I'm going to specify when I receive and my send. So that's definitely not what I want. Why do I not want that? Before we go through that, let's take a look at the example code real quick. It puts this multi-producer single consumer namespace. That's the only thing it does to let you know that this should only have one consumer. After that, it's just this channel abstraction that has producers and it has the consumer, which takes the channel and then does the thing on it. So the channel now has everything. There is no receive and send class. And this is not anywhere what I want. I can't enforce only one channel. I can't, or one receiver. I can't, and I start feeling like, I got to pass this same guy around, and I don't know in the code if I'm supposed to be receiving or sending with that or whatever it may be. And that's generally my objection to this particular example. And then of course this as well. I've got to enumerate all of the types first. Now, it took what I said, which was, makes it easy for the developer who's using the abstraction to find the correct type on the receiving side without having to know the details. Okay, I was thinking, just like we laid out, right? I have some sender, I have some receiver, I don't know have to specify the types in between. It's just easy for me to do that. Easy as in, easy for the developer to write the code, so to speak. It took it as easy for the person not to mess it up, which is a very valid interpretation of that sense. And then also it said assume a single receiver for each channel, not enforce a single receiver for each channel. Okay. Okay. Go. Go. Okay. Okay. Sorry, small technical difficulties. Okay, so the next prompt was, all right, let's wrap this in a receiving and sending class. Here's the thing. I honestly believe that the good results we got from this run were because it made those assumptions in the beginning. Because it made that assumption that the channel class was going to have to do pushing or receiving and sending algorithms. Okay, again, I'm speaking as though it knows something. I think really what it's doing is iterating over a history, right? The stochastic model and all of that follows out from this. But understand that because it made that kind of subtle assumption in the beginning, I got the best results from this run. And I'll show you what I mean later. Okay, so it's like, hey, Rust does this. This is great. We can just do that. And sender's copyable, receiver move only. All of this is good. Both are constructed by this make channel factory. And when the last sender is dropped, we'll do some reference counting thing. And of course the AI tells me, hey, good idea, you're such a genius, and I like it when it says that to me because it makes me feel good and all warm and fuzzy. And before we start picking this apart and going on more improvements, I want to talk about the variant overload. This is a really interesting piece. This is kind of like a known idiom, so if you use standard variant, then tune out for this slide. But if you haven't, I think one of the interesting things about C++ is that it's not parsable. So you can get away with all types of crazy things, like the overload extruct inherits all of the types and then pulls all of their operators down into itself, so that you operator overload on that. That's how the variant works there. The standard visit works with this overloaded type deduction. And there's an explicit deduction guide for C++ 17, but you don't need it in C++ 20.
Didn't they add this thing in C++ 20? Still overload or something?
I think it's still not standardized.
Yeah.
Yeah.
I think you can't say for sure. Yes. So okay. Yeah, is this pretty? I don't know, but I think it's a neat trick, right? That happens because you can do multiple inheritance, and then you can kind of do this pulling in the operators. It's interesting, at least. But we don't need it because we're going to go away from standard variants right now. Okay. In my humble opinion, I have problems with this. Okay, I'm not in plan mode, so AI didn't get a chance to ask me. Okay, so don't come at me, bros, AI bros. But the type safe senders receiver is good in theory, right? Oh, I'm going to make sure that all my users always get the right type and that they are never wrong. But it kind of sucks in practice. Why? Because I'm going to pass these things to my handlers, my handle classes. Okay, which means that all of those have to be typed. Which means that if I have slightly different, types with slightly different message requirements, I have to change them so that they don't do it. The alternative, of course, is that what do I do with the message that comes in that I don't have a receive handle for? Okay, I log it, I let you know that you've dropped it on the ground, and then in truth, in a practical system, when you're watching these data flows, you're adding these features one by one over time. And as you do that, if things aren't happening, you notice immediately. It's not something you're waiting for. And you can't get sometimes I get it and sometimes I don't. So the type safety only buys you pain in the implementation, and it buys you pain in the function, the member functions and the other functions you write for the classes that you need for whatever reason, the constructors, etc. And then when things go wrong, if you've got a giant list of types for each of the senders, suddenly you have a problem because it becomes very hard to read. And the other thing is the Rust idiomatic use of make channel. I actually like Rust. This is nice for them, but we can actually do something that's better for the user in C++. Take advantage of our non-parsability. Okay, so some pictures. I have, class A, class B, and class C. These are object instantiations of these classes. Okay, each of them has a receive queue, and the receive queues, the handlers from these receive queues are sending to the other receive queues in class A to class B and class C. Okay, and then each of these are running their own thread. So here's the question: if I want to abstract out all the pieces that are the same, similar in this picture, and what's the type of the receive queue, right? And ultimately it changes depending on what class you're in, and it's just a pain. I can't do something like that. Instead, I have to do something kind of like this, where I abstract out maybe the receiver and it does this thing. This is the problem with make channel. So the other thing is that make channel forces you to instantiate it at the moments, right? So I have to make my channel, my receiver, my sender, and then pass them to the specific thing. What does that mean? That basically means that I lose this ability to just have this nice, internal. And not only that, but since everyone needs this receiver anyway, why don't I just make it part of the abstract class that I'm going to inherit from? Okay, then I have it one place in the code, and everybody inherits from that. Okay, and then I get it for free, and I don't have to worry about my developers, doing their own thing or deciding, I don't need that, and I can do my other thing. I just tell them, hey, just inherit from this class, and we'll set up everything for you basically. So they're in the system already. Okay, so all right, next prompt. I'm not sure why I do this. I just do. I would much prefer if we didn't have to specify the type that they are being sent and received at compile time in my types, okay? So let's make it so that this is type agnostic. I would prefer if senders were constructed from receivers rather than having to call make channel to get both initially, okay? Both of those things, it's a meaningful shift as it says. And it is, significantly underneath the hood. It had to do quite a bit of changing. So this is exactly the type of change I wanted. It starts saying things that I like, okay, we got lambda traits in here. We're going to store some message base, which is interesting. It's an alternative to doing standard any, and it has benefits and downsides. So this is the type erasure part, right? This is the message base that is a virtual function that doesn't really do anything. And then all the message holders have a special type, and they inherit from message base. And so then I can create a pointer to them, and then store the pointers to the message base, and later get them out. What does that mean, though? There's no type index in here, which means I have to do dynamic cast. Turns out that that's actually okay. In certain systems, I'm not high frequency trading, so every nanosecond does not count. But yeah, some people don't like that on principle. So there are faster ways to do this.
And they're really expensive.
Dynamic cast?
Yeah.
20 nanoseconds. Not too bad. Well, let me say this. Because of the way that you're doing you only know exactly what type of queue you're on, right? You only know what the message type is. You're only doing 2 or 3 of them per look. And if you start at the end and you happen to get to the end, you only do 1. So the fact that you're specifying, I'm only looking for these types and not all the types in the system, actually they don't do too bad. And this is just from my limited experience with, certain systems that are out there in the world. Again, it's not like they can't go faster. It's just that this actually doesn't break the bank. There are other things that break the bank first. Okay, so we have to look at the template method programming change. If you were at the talk this morning in this room at 9:30 or whatever it was, 11 or right before lunch, this will look familiar. I learned a really neat trick in that talk about how to make this type of thing go away by inheriting it. So that's interesting. But it's basically, this is very simple meta template programming that the AI gets right. It knows you got to do the k type t if you want to not worry about constants and references. It knows you need multiple of these guys for like const no except and const. And the normal one with no and just no except, right? It also knows how to do it for function pointers and standard function like targets, which is interesting because that was left as an exercise to the reader this morning. And then the magic thing that makes all of this go is, down here. There are lots of talks about how this works in detail. But the point is that the AI got it right. And so it's interesting. Let's take a look at the rest of it. I got really worried when I saw this sender tracker structs for declaration and this enable shared from this. Oh boy, what are we doing? That's extra levels of complication I didn't expect. But in the channel implementation, it has push, pop blocking, and pop 4. To me, that is interesting because when the AI when I prompted the AI in other iterations of this for this talk to try to narrow it down to what I wanted to actually talk about, it didn't do that. It made this a private, just a state basically struct, and then made them friend classes, and then you had to do the locking at the top at the lock level. What does that do? The receive side now has all the receive code, and the send side has all the send code. Okay, they both have to do locking. But they keep their separation of responsibilities kind of different, right? And that's kind of how you would maybe articulate that if you were to do it. Some people would like that better, right? They would say, hey, I don't want my receive code in my channel abstraction. It should just store the state. I don't want to mesh the channel and the sending abstractions together. However, I like this best. Why do I like this best? 1, locking happens in one class. I can look at all the things and I can make sure that it happens in the right places. And 2, and this is probably the most crucial one, when I return values from pop to the receive side, it doesn't have to manually release the lock before calling the handler. Okay, and that right there is worth the whole ball game to me. Because a lot of complicated code has to happen just the right way so that it doesn't deadlock if you send another message onto your queue from a handler. Whereas with this, that falls out naturally. And then on top of all of that, I handle all of my synchronization in one class, one area of the code. All right, and then on top of all that, I got this weak pointer, the sender tracker thing. I do this, what I would consider fairly complicated, double reference, cyclical reference counting to make sure that, I create senders if I need them, I lock them, if they don't exist. And the whole intention is just to make sure that once all my senders go away, I automatically close the queue. I don't have any interest in that. It just feels like a lot of complication that I don't necessarily need. Okay, class sender gets forward declared. It bothers me. I don't. In every implementation that I like, that's never necessary. But the AI had to do this multiple times, and when I asked it why, it got into this thing. Why receiver came first? It couldn't come up with a good argument. It said that it's because receiver is what you receive first, and so naturally that's what it put in the file first. But we'll see why this is slightly annoying in a second. So nothing special here, but notice how much shorter the receive and handle code is, right? I'm just pop locking. I'm checking if the message is there. Otherwise, I return false. Otherwise, I dispatch on the handlers. The dispatch code is static code, both, so that this is kind of considered, when I asked the AI why it made them static, it said basically that it was trying to group these. It thinks it was grouping these as like it doesn't touch anything in the class, which is interesting. I mean, that's true, right? It's a private function that doesn't touch anything. This is a lambda folding technique, right? I'm going to try one, and then once I hit one of them, I'll short circuit and return. And then there's our special meta templating type here, right? To figure out what my type is from my handler. So it's more compact here. I don't have to worry about any synchronization primitives at this level, and the only objection I have is that my receiver has a friend class sender, and I'm not entirely sure why that's necessary until I see this. Okay, and what this says is I'm going to create the sender from the receiver. Okay, that's what I asked it to do, but I don't have to do it that way. Okay, and because I do it that way, I need to have my friend class in my receiver, and I got to do this thing where I do this out of line definition at the end of my sender class, because the sender isn't complete by the time I'm making that declaration in the receiver. So there's nothing wrong. This code will compile and it will be fine. It's a little annoying to like pull it out into their own individual files, because like this definition is at the end of your receive, the end of your send. But it's not the end of the world. That being said, we can clean it up. So by removing the sender constructor, and it works with the receiver, and instead construct it privately from a shared pointer to a channel implementation and a sender tracker, right? So basically I say, okay, I don't actually need to take a receiver because I'm just pulling out those values anyway. Just give me those values as my constructing. Then my sender will then depend on those types. I can put my sender first, and then my receiver, my sender is the only thing that has to have the receiver friend. And the fact that it does have the receiver friend, I can then do something like make that sending thing a private constructor. Okay, and then I get this nice little capability where my receiver is senders cannot be constructed incorrectly with values like the make channel value or whatever. So I fat fingered the prompt, but it did get it right. Okay, so what are we missing now? We're almost there. We've got the receive queue, we've got the thread, we've got the classes, all fine. But sending messages to myself on a timer gives me periodic events, okay? And that allows me not to have to worry about signal handlers and locking safely at the top level. I can get these things to happen. It allows me to maintain my view of the world as single-threaded. As long as I stay away from global variables, I'm golden. Not that people haven't come up with correct ways to mess this up. I guess technically this is true. You can pass a shared pointer. However, I argue that if you're passing a shared pointer to another thread and it's unprotected, that's on you and I can't help you. How do you do this? Priority queue is really nice. It has often surprised me when I'm not specific about this particular prompt, the crazy interesting alternatives to priority queue. For instance, it will do things like standard list, and if a message is not received, it will just leave it there for some one day when you decide magically that you will handle that message, which is fascinating because you don't have a registration, so you can't add messages, so that will never happen. So I don't know. But this actually, where it made the message base mutable, is something I had not considered, and I'm probably going to steal. Because if you ever mess with priority queue, you know that it has this really annoying thing where you can look at the top value, but that's constant. You can pop the top value, but you can't get the value back when you pop it. So when you pop it, it returns void. So you have to either do the thing that you're not supposed to, const cast away the const and standard move, okay, and then pop immediately afterwards, and that's considered the idiomatic way of doing that. But it will not get you past Parasoft. So,
But that's done for exception safety.
what, sorry?
That's done for exception safety.
Right. Yes. Yeah. I mean, there are legitimate reasons not to do that, right? And then, but this is the other way, the mutable message, right? Okay. So I just move out of the mutable message from my standard move, and I can do that without calling constcast. Yes.
What's Parasoft?
Oh, it's a C++. Oh, it's not just C++, but it's a static code analyzer. And so it's used heavily in things that like have to have some type of guarantee. They want some type of guarantee that the code is saved. You can think of it as like C++ rules on steroids. They do things like SEI certs and stuff, other stuff. Airplanes use them a lot. Defense industry uses it a lot. Okay. All right, so there's some other things that the AI got right. It has messed this up before. So the condition variables, if you don't do them exactly right, if you mess up the logic a little bit, then you can get blocking forever. And so it's very important that you unit test the crap out of these things, but also that you look through it and make sure that it is right. This particular implementation did the safest thing possible. Every time a message gets sent, it notifies every thread and just says, hey, wake up and see if you can handle this. That guarantees that it'll come out and do the while loop. The one particular corner case that I see AI mess up most often is if I have a scheduled message, I check my message queue, I discover that there's no messages on it, so I go into the forever wait. It then has a predicate that it uses where it only checks to see if there is a message ready for that to happen, for it to move on. When it does that, if you receive a scheduled message that is in the future, basically it will say it's not ready, and so it will then go back to waiting. But that is a bug because you have something that will be ready shortly. So this doesn't have that issue because it notifies all the time, and then it goes to the while loop and rechecks your logic. But there were iterations that was not the case, and it's kind of a really hard thing to like see and know and like get correct. So and this is like the it doesn't have a ready. It has a ready at that it's actually checking on the value. So like there's some logic in there to actually run and do that type of thing. But there's been iterations where it tries to build a ready function that does that checking for you, and you have to be careful when you do that. Also, I feel like when there's overlap like this and it doesn't have functions that it calls, like it just doesn't feel dry enough to me. It makes me nervous. It makes me nervous to have code that's not dry, that's condition variabled and synchronization, because if there is a subtle bug and I fix it there, I gotta remember to fix it everywhere. AI doesn't care about that. AI is like, I'll obviously fix it everywhere. But it makes me nervous for maintainability.
That's like the fundamental danger of writing code with AI. It writes for itself, assuming
Yeah.
it can infinitely refactor.
Right. And I mean, so, when we talked about the types, right? The only thing AI cares about potentially there is token, like the token context growing, right? But it can definitely go through and like look maybe at all of the types and like sort that out. But as soon as you go to read that, it's incomprehensible, right? So, and that's the type of thing is like forcing it or encouraging it away from those type of decisions are where most of my prompts I felt like went. And then here's where like this thing. Okay, let's remove the reference counting in the abstraction. I don't like it. It's complicated. Replace it with a closed queue struct that if the receiver thread receives, it will close the queue and throw an exception. It complained about this change. It was like, listen, you're relying on the user to do it right. This is it's more direct and it's simpler, but someone can mess it up. And my response to that is like, yeah, this is going to happen when you shut down. Okay, for my system, this is simpler. It keeps the code easier to read. And, I have to get the cleanup right, but I'm not super stressed about that. It's fairly easy to do. And even if I get it wrong, I'm going to reboot in a second anyway, okay? I would prefer that to this weird cyclical pointer of thing that we built before, okay? Now, that's for this system that, that I decided that's not necessarily the true and good and all thing. All right, so I tried to prompt from scratch a couple of other times, okay, at the end of this. I tried like slightly different starting prompts. My intention was either recreate my first attempt and like more closely get down to that first way I was doing things. Because I thought it broke in interesting ways that time. I thought it was like a nice story. In this iteration of it, it felt more like Junior went off, made some assumptions about what I came back, and then I got to see like another way in which the code was built or could be built. And it challenged my assumptions more on like, hey, are you sure you want it that way? Are you sure you want it that way? And then I was like, yeah, I do because of this, because of X, because of Y. And so it helped solidify why I was doing certain things that I was doing. And I also wanted to start with something broad because it was easier and it was faster. So I tried a few prompts, this was recently, I need a message patch, obviously the first one, right? I need a message patch that is thread safe, use C++20 to implement modern best practices. Oh, magic and godlike AI, please render unto me a most useful C++ message passing abstraction, no mistakes. Guess which one got closest? Okay. Yeah, the third one, okay? It is like, oh, let me build you a whole library, sure, okay? And this was, very interesting. I got channel, message bus, and then actor, right? Like the actor is ultimately where I want to go with this type of system. But it did build the whole thing. It didn't like build it of composable parts like the message queue. And the message bus was the closest to what I wanted, but the actor didn't use it. It just like copied basically the code down there. And the same thing with the channel. Like all of those abstractions were kind of built independently. So it's just another one of those things where like AI doesn't seem to care about dry. It doesn't seem to care about, and I'll say, the current model or whatever and yada, yada, yada. All this is not a talk about AI. But
have you tried asking you can ask the model itself, usually not in the coding agent, but just go to the chat and like talk to the same model.
Yes.
Say, when I talk to like, I don't know, let's say, well, okay, this probably wasn't Claude Code because I never got anything from Claude Code better than, okay, that's fair.
Yeah.
That's the biggest praise I got from it.
Yeah.
So, but you talk to it and it says, the reason we don't do this, meaning like LLMs, is because this and this, and yes, this is a known limitation, and there is a reason, like, we would duplicate rather than refactor and whatever else.
Yeah, the only time I ever asked it, like, why are you doing this, was when it kept giving me that out of order sender class when it put the sender class at the bottom, and the only thing it said was, I don't have a good argument for it other than the fact that like I think it's more natural to consider the receiver class first, and so it's not even a strong argument. I can change it really quick and it will fix all these things. Do you want that? Like that's
you
what
don't ask that session. You ask.
Oh, another session.
You ask another session in the general model.
I see. Yeah. I haven't tried these things, and
So
a lot of this
they're remarkably self-aware about their own thought process.
Yeah. Okay. Interesting. I and again, part of me is like it's a little bit of cheating. I've found a lot more success with plan mode where like it will ask me these assumptions up front, and then I can tell it do this, do this, and so. But this was useful at least in the sense that like, just like with anybody else, I give them a general prompt and they go off and do their own thing because they don't know what's in my mind, and then I can challenge my assumptions that way. And so it was just a nice different use of AI. Okay. Conclusion. System library design is really hard. I think it requires careful consideration of the developer's needs. I spoke very specifically, this is something I know very well, the use case I know very well, and so I know exactly what I want and why I want those things and how it doesn't necessarily go. If I didn't have that, it might be much more experimental. I might be okay with certain things until I actually go to use it, and that's why I think things like the Beeman project are absolutely necessary, because they allow us to get our hands-on use of these things, and that vastly accelerates what we can say about whether or not it's good or bad or what. Practical design doesn't always follow the rules. I said sometimes you break the object-oriented purity of something to get cleaner, simpler, and easier to maintain code. Like there was a legitimate use of friend class in here, and I generally don't like that. But my sender and receiver objects are coupled together, and I wanted them to be coupled together, and I wanted users to like make that hard for them to pull apart. I don't want them to take off just the sender abstraction and go run with some of the code. And on top of that, things like the queue, the channel state underneath, it having receiving and sending functions allowed my condition variables and my locks to all live in the same file. That gives me a limited area for deadlocking to occur, a limited area for mistakes of concurrency to occur. I like that. It also avoided some tricky mistakes that were made otherwise, particularly having to unlock before you called a handler function. And then also maybe there are uses for AI outside of quick prototyping. Everyone in this room knows that. It's for the YouTube, I think that it's useful. Results from single prompts are still unpredictable to me. I tried really hard to get repeatable results, and I could not. Now I know that's by design, right? Obviously, but it makes me nervous trying to build a business, in my humble opinion, off of something that I can't count on consistently and need some type of interpretation for. But that's a pitch for my next job interview. Okay, any questions?
So really nitty gritty question. Strictly DKT, I think, is incorrect here. I think remove CVRef is probably what you want. Did the AI ever this is a mistake that I see almost everywhere.
Yeah.
Did the AI ever do that right, or did it always select?
Always did it wrong. And
did you ask C++17 or did you allow it to use remove CVRef?
So
that's interesting. I only write on the latest standard, whatever the latest standard is at any point.
That's the reason they introduced remove CVRef. Because decay was broken, but at C++17.
Yeah, that's all you had.
That's all you got.
Oh, yeah, that was a specific C++17 prompt.
Okay, so they don't have remove CVRef.
Yeah. I forgot that they weren't introduced at the same time.
No, it was much later, and precisely in response to the fact that decay is broken.
Overly broad, yeah.
Yeah, interesting. Yeah, so it obviously didn't. But even when I said use C++20 and use best practices, if I remember correctly, it was standard DKT the entire time. But I think it's also because you see that all the time. That's what people do, right?
Yeah.
And I think that's what it does internally. I do know that. I had a thought, and then it'll come back to me. Anyway, yeah.
No, nothing stops you from writing your own remove CVRF. There is nothing C++20-ish in its
funny,
guts.
Yeah. Yeah.
Nothing's also stopping you from using C++20.
Well, yes and no.
Well,
So one
maybe
of the
not.
problems is that there are certain ARM compilers for certain systems that do not yet support C++20.
Yeah.
And so therefore certain projects are locked down to C++17 only.
Well, there are libraries. So, for example, we're in the process of porting to C++20. We have to port everything from, I don't remember, Qt5 to Qt6 or whatever, 6 to 7, whatever the version is, because the current Qt we're on cannot be compiled with C++20.
I see.
Language is not backward compatible.
Yeah. Yeah. Interesting. Okay. Any
So
other questions?
we're conditioned on like shifting this Qt, and they're not backward compatible either.
Yeah. This is always a great place to be.
Yeah. Oh, and while we try to use as little boost as possible, about a third of our boost stuff is broken when we try to move, so we have to move to the new version of boost. Again, some of the libraries that used to be there aren't there anymore. Some of them changed, so
Interesting. Yep. Any other questions? Okay, thank you. Appreciate it.